All right, well, hello everybody. Last topic before I come back is percent composition of a compound. When you get these types of problems, what it's asking you for is how much or the percent of each element in a compound. All right. So for the example that I had you do, potassium chromate, how much potassium, how much chromium, and how much oxygen is there now in this compound? Now, don't be fooled by the fact that there's 4 oxygens. We need to be in the units of mass. So if oxygen didn't have much mass, even though there's 4 of them and only 1 of these and 2 of those, it's not going to be the one that there's most of. It's whatever there's the most mass of. Okay, that's what will have the greatest percent. Right? Units have to be in mass, which hopefully you get from the periodic table. Right? So what we have to do for each one is we got to figure out how much potassium there are, how much chromium, and how much oxygen. So we got 3 different problems that we have here, all right? And that's just what you got to do. How many of our elements, that's how many problems you're going to have. So it's the mass of the parts of each of these elements, then we'll add the whole thing together, and that's what we divide by. So there's 2 potassiums in that formula there. And potassium's mass from the periodic table is 39.1. So that will be a total of 78.2, all right, divided by the mass of the whole thing, which I'm going to wait for to the end. I'm going to add everything together so I can see what that is. Chromium, there's 1 of them. Chromium, I believe, is 52.0. I'll double check. That is correct. So we'll divide 52.0 over the mass of the whole thing. And then last thing we're going to do, I have 4 oxygens, so I got to multiply the 4 times oxygen's mass is 16.0. All right, so add up 78.2, 52, and 64.0. It comes out to 194.2. That is the mass of the whole compound, K2CrO4. And that's what we divide everything by. And then finally, to get out of our decimal and have a percent, you got to multiply by 100. All right, so there's my 3 problems set up just like that. It is that easy. It's just how many ever atoms of each element times that element's molar mass, and then you're going to divide what you have there, your parts, by the whole. You should have come up with 40.3% if we round to 3 sig figs. You should get 26.8% for that one, for chromium. And then finally, the rest will be 33, and we got to round this to 33.0% if we want to have 3 sig figs. Now, one thing I want to be clear is you can definitely check and see if you did a good job here. All these, okay, should add up to 100 or very, very close to it. If you add this up, it comes out to 100.1. If we added more sig figs in our masses, actually right here, if I added a couple more, trust me, sooner or later we'd get to right exactly at 100. But if it comes out to 100.1 or 99.9, you can feel confident that you did a good job. So what this means is, in this compound, 40.3% of it is potassium, 26.8% of it is chromium, and a third, 33%, is the oxygen. Okay. All right, well, look forward to seeing you tomorrow.